Hello everyone, my name is Aditya Tiwari, Assistant Professor CSV2 Bhilai. In this tutorial, we discuss about Radix sort algorithm and sorting application. So, sorting is a technique to rearrange your data either in ascending order or in descending order. So, there are a lot of sorting technique by which we can sort our data either in ascending way or either in descending way. So, Radix sort is one of the approach to rearrange your data in that particular order. So, Radix sort algorithm comparison by creating and categorizing elements based on their radix. For elements with more than one significant digits, it repeats. M is a non-comparative sorting algorithm in computer science. It avoids the bucketing process for each digit while reversing the previous steps ordering until all digits have been considered. Radix sort and bucket sort are almost equivalent. Bucket sort goes from MSD to LSD, while Radix sort is capable of both direction in LSD also, in MSD also. Here you can take a look at bucket sort algorithm with time complexity also and pseudocode and also the application of this Radix sort. First, we understand the concept of Radix sort, why we required and what is the main purpose of Radix sort algorithm. So, Radix sort is a linear sorting algorithm. Radix sorts time complexity of O of ND, where n is the size of the array and d is the number of digits in the largest number. Suppose we having a values like 999. So, here we having a 3 digits, the maximum place digits is 100 place, ones, tens, 100 like that. So, D is indicating the largest number, the largest position number where the largest value will be holding in which tens format. So, it is not an in place sorting algorithm because it requires extra space. Radix sort is a stable sort because it maintains the relative order of elements with equal values. Radix sort algorithm may be slower than other sorting algorithms such as merge sort and quick sort if the operations are inefficient. This operation includes sub, insert, list and delete functions and the process of isolating the desired digits. Because it is based on digits or letters, Radix sort is less flexible than other sorting techniques. If the type of data changes, the Radix sort must be rewritten. By this example, we can understand the concept of the Radix sort logic. Suppose we having a values in a lot of format. So, in the first table we having a lots of value like 132, 543, 783, 63, 7, 898 and 49. So, first you fill these, put the 0 marks in the prefix of there where the number is like 7, we have to prefix the two zeros. So, because of our highest digit number in that particular table is 898, that is why we can say the maximum position value is comes under the 100 place, that is why we fill the prefix value 0 where the digits are values are like 7 or 49, we have to prefix the 0 value. Now, in a first table you have to concentrate only the ones place values, like here we having a numbers in a 3 digits. So, first is a ones place, second is a tens place and third is a 100 place. So, don't go for the tens or 100 place, first you have to focus on the ones place value. So, here we are having a ones place values like 2, 3, 3, 3, 7, 8, 9. In that way, you have to rearrange your data as per the ones digit number. Suppose the number are given in this format. So, you have to take a smallest value at the upper end as compared to the lower, the bigger value as the lower end. So, you have to 2 should be the first value, arrange your data and 2 should be the holding the top position. Then the next increment, next bigger value like 3, next is 7, next is 8, like next is 9. In that way, you have to rearrange your data as per the ones place. Don't go for the tens or hundred place. They are the data are rearranged, but they are not the as per the situation. So now in a first table you have to rearrange your data according to the ones place values. Now in a first when once you completed the ones place data, you sorted your data at the position of ones place. Now go for the second table. Now you apply here, you focus on the tens place data. Don't go for the ones place or the hundred place. You have to focus on the tens place data. Now again rearrange your data as per the tens place data order. So again you rearrange your data in a sorting format, like starting from 0, 3, 4, 4, 6, 8, 9. In that way you have to rearrange your data according to the tens place. Now once you completed tens tens place value you completed. Now move on the next one, that is the last one is a 100 place value. Now move on the 100 place. Now you have to focus only the 100 place data. Now again rearrange your data by the in a 100 place, and according to that one, first to fixing the value like 0, 0, 0, 1, 5, 7, 8. When you completing all three tenses, three units of data, you have to see in the last table your data will be sorted. In means the smallest value is 7. That's why the 7 are in the are holding the top position. After that 49, after that 63, after that 132, after that 543, after that 783, after that 889. So according to this concept, in our first table we have to focus only the ones digit. We rearrange the data in a ones digit units. Then we go for the second table. In a second table we take an input from the first table. Then again we rearrange the data as per the only the tens place data. We focus on the tens place data and we rearrange the data as per the sorting order. So what we will get output from the second table, it should be an input for the third table. Then we take that particular data into a third table as an input. Then again we concentrate only the 100 place, and according to 100 place we rearrange the data, and finally what we get the output, or we can say we get the sorted data from the last table, that is the third table. So this is a 3 unit digits. Suppose we having any data having a 4 digit units. So again we go for the 1000 place also. Again the digits is means ones place, tens place, 100 complete depend on the number of digits, is how many number of digits are available in particular data. Suppose we having a 5 digits number, definitely we go for the 100, ones, tens, 100, 1000, 10,000 like that. Suppose we having a 6 data, so we go for the lakhs of the numbers of that one. So again completely depend on the how many Ds are available in a particular data. So according to that we have to put the tens, 100 place units values, and based on that one we rearrange our data one by one. First we go ones, 10, 10, tens, then 100, then 1000, 10,000. In that way we have to rearrange data. Finally the last output comes from the table, that is a final data. Like like this example, in the third table we get the perfect output of this all the data, and we get the data in a sorted way. So working of the Radix sort algorithm. So Radix sort algorithm works by ordering each digit for least significant to most significant. In base 10, Radix sort would sort by the digits in the ones place, then the tens place, and so on. As I told you, if the digits are come in the 10,000 place, so you have to sort out the ones, tens, 100, 1000, 10,000. That way you have to complete depend on the how many Ds are available. To sort the values in each digit place, Radix sort employs counting sort as a subordinates. This means that for a 3 digits number in base 10, counting sort will be used to sort the first, 10th and 100th places, that resulting in a completely sorted list. Here a rundown of the counting sort algorithm. So assume you have an 8 element array. First you will sort the elements by the value of the unit place. It will then sort the elements based on the value of the 10th position. This process is repeated until it reaches the last significant location. Let's start with we having a numbers like 132, 543, 783, 63, 749 and 898. It is sorted using a Radix sort. As illustrated in the figure, we can see find the array largest element, that means maximum. Consider A to be the number of digits in a maximum. A is calculated because we must traverse all these significant location of all elements. The largest number in this array is amongst of that 132, 543, 783, 63, 749 and last one is 898. So, the biggest value is that 898. It has 3 digits. So, as a result, the loop should be extended to hundreds of places. That's how we can find out. We can find out from the biggest, largest value amongst all the number from where we have to sort our data. So, 898 is the biggest value and you focus on that one. 898 the places, the maximum places 100 place. So, we can say we have to apply the loop up to the 100 place only. So, in this case we have to apply a 3 times loop. Now, go through each significant location one by one, sort the digits at each significant place with any stable sorting technique. You must use counting sort for this. Sort of the element using the unit place digits like A equal to 0. So, first we insert our data in all the array. So, put your data inside the array. Now, count the indexing like a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, now up to the 9 and you have to put the all this value. While we get the output, here to focus only the ones place, no don't go for the tens place. So, after you applying on the ones place data, what you will get? You will get first number digit is 2, then second number digit is 3, then again 3, then again 3. Here we having a 3 data item which a last value having a 3, last value is a ones place value is a 3. That's why all 3 are in the same segment. So, when we having a same data, so as per the first come first serve principle, where which data will become had come at the first time, it will go for the first come first serve executions. So, first one is 2, there is no any competition with 2, but in a 3 we having a 3 datas, but first come first serve, as per the first come first serve we take our data in that particular order. So, the second one is 3, then again 3, then again 3, then next value is 7, then 8, then 9. So, indexing will be reduces. So, 0 to 9 indexing will be reduced to 0 to 6. Now, what we get the output by the ones place or table, we get the output 132 comes under the first position, then next one is 543, then next one is 783, then next one is 63, then next one is 7, then next one is 898, then next one is 49. So, this output comes from the ones unit table, but this is not a perfect result, or this is not a right answer of the sorted data. This come only from the ones place data. So, this is output from the ones place. Now, we apply this output as an input to a second table where we focus on the tens format. Now, take data as a input in a second table. Now, here you focus on the tens place. So, when you focus on the tens place, so you first focus, don't forget about the ones place or the 100 place data, only concentrate on the 10 place data. So, as per the data, you rearrange your data like that one 0, 3, 4, 4, 6, 8 and 9. So, all are the data as per the tens format, data are come in this order. So, we take also a prefix and postfix value of the order of that particular data, like the first value, the output of the second output of the tens place unit of data, that is 007, 132, 543, 49, 63, 783, 898. this is output of the tens place data. Again, this is not a end of our result, because here we are applying a loop only 2 times. Now go for the last loop. Now this output will be as an input for the third table as an input. Now here we focus on the last digits value, that is called a 100 place result value, and this is our last loop also. So now focus on the last digit. This means a 100 place value as per the order. First we rearrange the 100 place data like in 0, 0, 0, 1, 5, 7, 8. Now take all the prefix, postfix value and arrange your data, and the final output of this 100 place data is 007, 049, 063, 132, 543, 783, and last one is 898. Now we can't go for the next loop, because as per the logic only 100 place data and it may d equal to 3. That's why we can say we will be applying a loop only 3 times, and what we get the output after the 3 times loop, that is a final output. So this is our final output. So if you cross check here, the resulted data, all data will be in ascending order. So we can say this data is a sorted way by the using of the Radix sort principle or Radix sort technique. So the 898 is the biggest element, it is holding on the last position, and 007 is the smallest value, that's why we are holding the first position. 007 is a gems bond number holding the first position, and 898 is the biggest value holding the last position, date indexing. So this is a way to approach to sort our data using the Radix sort technique. So now we go for how we design an algorithm. So this is a concept what we discuss right now. So all are the concept. This is based on the example. Now we go for the how to create a algorithm, or we can say pseudocodes. So the Radix sort algorithm makes use the counting sort algorithm while sorting is in every phase. The detailed steps are as follows. In step number 1, check whether all the input elements have same number of digits. If not, check for number that have maximum number of digits in the list and add leading zeros to the ones that do not. So first to cross check all the numbers are in the same units places or tens places or 100 places or like in any d places. If data is not in that format, you have to put the 0 as a prefix of any value. Like that in the previous example, we put 2 zeros in the front of the 7. That's why you can put 2 zeros as per the maximum value. Now in step 2, take the least significant digit of each element. In step 3, sort these